Hi, my name is George Woodbury from College of the Sequoias in Visalia, California, and in this video we'll learn about what logarithms are and how to convert back and forth between logarithmic form and exponential form. Let's begin with a logarithm. I've got one written on the screen. This is read as logarithm base A of x. The base is written a little below the line. What we're taking the logarithm of, that's called the argument. And the number a is referred to as the base. Okay, so what does it mean? Well, this is basically an exponent in hiding. This is the power to raise a to in order to equal x. For example, log base 5 of 25 means what power do you raise 5 to in order to get 25? And we know that 5 to the second power is 25. So this logarithm is equal to 2. So again, it's basically an exponent in hiding. We're going to start by going back and forth between logarithmic form and exponential form. We need to be able to go back between these two equivalent forms of an equation because sometimes when we have a logarithmic equation, we can solve it by changing it to exponential form, or if we have an exponential equation, we can solve it by changing it to a logarithmic form. The logarithmic form is written on the left, y equals log base a of x, and in this terminology, a is positive and not equal to 1, and b is positive. Not b. X is positive. Y could be any real number. To convert something from logarithmic form to exponential form, we're trying to make an exponential equation out of it. And what we need to do is take the base a and raise it to the power that's on the other side of the equation, which in this case is y. And when we do that, a to the y power equals x. That's the exponential form, two equivalent forms of the same equation. And we need to be able to go back and forth between these two. So I've got 6 examples for us to work through this. I'm going to put the answers in red. And in the first problem, problem A, we have 3 to the second power equals 9. That's an exponential form. To change this to logarithmic form, I'm going to write it in the other order. So I'm actually going to put the logarithm first. And so I'm going to write log, and then I'm going to think about, okay, what is the base here? And the base is the base of the exponential expression. It's 3. The exponent goes on the other side. That's where the 2 goes. And the number that was on the other side, that's the argument of the logarithm. So log base 3 of 9 equals 2 is equivalent to 3 squared equals 9. Let's try to work it in reverse for the second one. Log base 2 of 16 equals 4. Take the base and raise it to the number on the other side. 2 to the 4th power equals the argument of the logarithm 16. For part C, I've got 10 to the 5th power equals 100,000. What is the base of this logarithm going to be? It's going to be 10. Now, a lot of times students are tempted to put the 5 next, but the 10 and the 5 are together on the right side with exponential form. They can't be together also in logarithmic form. So we always move this number over to join the logarithm. So it's log base 10 of 100,000 equals 5. And again, if you think about changing this back, 10 to the 5th power is what we're looking for, and that is what we have over here. One thing about log base 10, this is called the common logarithm. And often we'll see it written without the base at all. So when you see log 100,000, it's understood that there is a 10 there. There's another one that we don't write the base for, but we'll talk about that in an upcoming section. I left off part of part D. Let me add that in. Let's see if we can figure out what's missing. Remember, a logarithm is the exponent that you have to raise the base to in order to get the argument. So what power do we raise 5 to in order to get 1 over 125? Well, I know it's negative because the power of 5 is in the denominator, and because 125 is 5 cubed, this should have been -3 there. Okay, in exponential form, that's going to be 5 raised to the -3rd power equals 1 over 125. For E, we have 7 to the 1st power equals 7. Log, what's the base? The base is 7. What's the argument? It's the number from the other side, also 7. What does that equal to? The exponent, or 1. In the logarithmic form, this number that's on the other side, away from the logarithm, that is the exponent. By the way, it doesn't matter, whenever the base and the argument match like we have here, it will always equal 1. So for example, for any positive base a that's not equal to 1, log base a of a will equal 1. For f, log base 9 of 1 equals 0. Take the 9 and raise it to what's on the other side, 0. Set it equal to the argument. So 9 to the 0 power equals 1. This one is true no matter what the base is as well. We'll talk about this in a later video too. Log base a of 1 equals 0 for any base a that's positive and not equal to 1. All right, so that's a quick explanation of logarithms and how to go back and forth between logarithmic form and exponential form.